Peace, welcome to the room. Welcome to the room. Alright. About to get into some calculus right now. Alright. Um so if you made it this far, congratulations. Pat yourself on the back. Alright. So the textbook we got today is calculus alright. From Cengage. So this is around chapter 4.4. And we're, as you can see, we're about to get into indeterminate forms and L'Hopital's rule, right? So that being said, suppose we are trying to analyze behavior of a function. Let's see how I'm gonna be able to do this. So we'll just go through some of the homework problems. All right, so we can well explain everything while we go through the assignments. All right, so let's go ahead. Let's go and do some functions right now. Let's see here. So given that, let's see, the limit of f of x equals 0, x approaches a, right? You can actually graph that, right? You can graph this, right? This is the y-axis, the x-axis, right? 0 is also c, right? So let's just put c here, bam, because 0 is the slope, right? And this is the function. Got that 2, 4, and 6, right? So as the slope passes through, see this function passes through, the constant is always 0. Alright, as x approaches a, you see x starts here at 0. Let's say you can end right here. Let's say this is a right here. As x, which just starts at 0, approaches a, f of x is 0. The slope is still 0. It's not, going up and going down. Nah, it's just straight line, horizontal asymptote. All right. So that being said, let's keep going right here. The limit as x approaches a for function g of x equals 0. Right? So that's saying that as x approaches a, as the x-axis, this domain, right? And obviously this is all positive numbers too. So it's basically 0 to positive infinity, right? That's all we're focusing on. We're not focused on negative. This is the domain from 0 to positive infinity. So as x approaches a, g of x equals 0. All right, and let's do this one. The limit of h of x equals 1 as x approaches 1. Right? What does that mean? Well, basically saying here's 0.5 and here's 1 and here's 0 and this is x and this is y, right? And the curve that we're going to create is 1. This is 1. So as 1 passes on, and this is a horizontal asymptote, right? As 1 continues throughout this line to infinity, well, actually no, because it's not infinity. Actually, let's go ahead and do this part right here. Hold on 1 second. So it's going to stop here at 1. All right, x is going to go from 0 to 1. All right, from 0 to 1. That is, as h of x is 1, right? When x is 1, y is 1, and that's right here. Got another one. Here's another one. the limit of g or q, let's use q instead. The limit of q of x approaching infinity as x approaches a. Right? So as x approaches a, g of x is going towards a positive infinity. You see what I'm saying? So it never touches a, but it gets very close to a. So it goes like that. Something like this is very similar to, like, I'm trying to figure it out. I think it's like that, but this is, you know, a polynomial. This is a polynomial. But nonetheless, we get to graphing next. But yeah, so this is it. So that's just a graphing mixed with it. So given these, right, you got f of x equals 0 as x approaches a. You got the limit of g of x equals 0 as x approaches a. You got the limit of h of x equals 1 as x approaches 1. And you got the limit of q of x is equal to infinity as x approaches a, right? So the limit, let's go right here, right? The limit, the limit of f of x as g approaches x as x, wait, the limit of g of x divided by the limit of f of x over g of x as x approaches a is what? That's a good question, right? Because as we can see right here, right, the limit of f of x as x approaches a is 0, right? And the limit of g of x as x approaches a is 0, right? So if that's the case, then that function is my apologies, indeterminate. All right. So basically, all we were doing here was just taking, we were just taking these rules, right? This is a rule, right? A set of instructions. We're taking note to such instructions taking note to such instructions, and so all right, and man, this doesn't have the this doesn't have the erase button, so browser. So nah, it should be. Dang, we should have something better than that. There we go. There we go. Alright, cool. There we go. Yep. Alright, we're back in action. So, we're working on the L'Hopital's rule right now, and so we're just going to be providing these given functions, okay? And so let me write these back again. The limit of f of x equals 0 as x approaches a. The next one's the limit. And if this is your first time taking calculus, man, if you taking calculus and you haven't done math in close to a decade, my hat to you. You see what I'm saying? I'm gonna come across quite a bit of people that, you know, took on the work to become knowledgeable, you know, in high mathematics. And I keep it 100 with you. You know, when I got back into college, I didn't take pre-calculus until I was 32 or something like that. You see? And when I went back and took it, remember, this is the pre-calculus, which includes trigonometry. 3 months are, you know, let's just say 1.5 months of trigonometry crammed up, and then pre-calculus, you see? So I went back into college like that, but I got a B in there. But I'm going to tell y'all one thing. I did get a D or F. I did not pass my first year of calculus. I'll just say that. I didn't pass my first year of calculus. And so, but I didn't stop, you know what I mean? I had crammed quite a bit of courses that semester in the first place, and I said, well, I got calculus, I got data structures, I got C++ programming, I got intro to philosophy, I got, you know, a big load. Now if I could take C++ over the summer, I would, but I can't. They're not offering it, so fuck it. I'll just go ahead and take calculus over. I'll take it over summer. Why? I already spent the whole 3 months in it. You know what I mean? It's just going to be a review, and you know, it's better than getting a C in it and spending the whole summer, you know, doing some other stuff, just making money, and then go back to college, go back to school 2 months later and forget about everything. I was going to do that to myself. You know, I had the Most High had a bigger plan for me, as much as myself. So nonetheless, back to the game like we never left it, Morris. As you can see on the screen right here, dang, I gotta put it right here. So up here, this is the limit of f of x is 0 as x approaches a. All right. All we're doing, let me just put like this right here. It's a great divider. All right. All we're doing is just looking at this, and we know we're referencing the function to the expressions above, so they're not going to be different. You can separate f of x and p of x too, right? You know, it's the same thing. So, but nonetheless, the limit of x is of a, the limit of f of x, x approaches a is 0, all right? It's 0, because it says it's 0 up here. The limit of p of x, where's p of x? Right here, infinity. The limit of p of x as x approaches a is infinity. So what we're going to do, put 0 over infinity. You feel me? 0 over infinity. Right? It's nothing more than that, man. It ain't nothing more than that. You see what I'm saying? So, common sense would tell you when you divide something by infinity, when you divide 0 by infinity, what is it? You divide anything by 0 is what? 0. That's it. That's it. Alright? So now, you got the limit as x approaches a, and then we have h of x divided by p of x, right? So what is h of x? H of x is right here. So just like down here, the limit of h of x as x approaches a is 1, right? So you do 1, and you got the limit of p of x as x approaches a is infinity, right? 0 divided by infinity is what? 1, excuse me. 1 divided by infinity is what? Right? According to that rule, 1 divided by infinity is 0. Alright? 1 divided by infinity is 0. Right? So all we did is don't overlook it, man. I'm telling you, when I first looked at this, I was like, what the, you know what I mean? But then it started making sense. You just look at it more and then you just work with it. You see what I'm saying? It's like having a flat tire and just looking at it like, fuck. You know, eventually you get over the fuck. You know, be like, you know, you get over the damn, right? And then you're like, all right, well, I'm not going to be stuck on the side of the road. I'm going to figure out how to fix this flat tire. You know what I mean? I do have tools, or I do have references, you know what I mean? Like, just like you have up here, right? And just put it together. You know what I mean? And you got one more right here. Let's do one more. So the limit of p of x as x approaches a, p of x divided by q of x, right? So the limit of p of x as x approaches a is what? P of x is infinity, right? So infinity divided by, so the limit of q of x as x approaches a is infinity. So infinity divided by infinity is what? Indeterminate, right? In, no, man. Alright, let's just fix that back. Yeah. So, indeterminate. Alright? Infinity divided by infinity is indeterminate. We can't have that shit. Alright, so what do? That's what this course is about. We about to include L'Hopital's rule and get to it, man. Shit, you know what I mean? And if you need some water, get your water. I got my Moroccan coffee. Man. Alright, so here we go. Let's go into the next one. Let's see here. Cool. So that being said, now we're into indeterminates, and so that was a good intro right there. I really like that. So let's go ahead and do this right here. Let's see. The limit. This is an L. Man, that's horrible. Let's write that back. To be honest with y'all, man, I was really into like making these videos, YouTube videos, while I was doing in the beginning of the semester, and on my calculus journey. But I just said, you know, I had the time or whatsoever. But then once I realized, oh man, shit, I'm taking this shit over. You know what I mean? It got more, you know, I was on my own pace, you see. And then from like now to like, you know, like I think like I got like 3 more weeks for you know. Let me speak like I'm speaking into the future, right? So, after that semester, I was like, oh man, once I had, I didn't drop it. I just, I know I'm not the one that just quit shit. You know what I mean? So I was like, all right, let me just, you know, go at my own pace. And when I did that, then I had like, the time to be like, all right, I didn't really stress. Say, man, I'm gonna take this over in the summer. It's okay. Let me just go at my pace. Let me make this recording so I can go back and review. You feel what I'm saying? And then that's why, like, I was there watching these vids and like saying, cool, I understand that. And I like listening to my voice too anyway, so shit, it worked out for me. Passed the class, and I got into Cal too, right? So, that being said, so this is what we have here. We have the limit of f of x divided by g of x as x approaches 2, right? And so what we're going to do is include the 2 in these right here. So let's go ahead. The limit, wait a minute, as x approaches 2. F of x. Let me get 1 second, see where. Well, shoot, yeah. Let's just look at the homework. Let me go ahead and review this homework first to see what is that number. 5. There we go. So we have these tangent lines here. So use the graphs. So it would be important for me to actually draw a graph so you can see what we talking about here. So that being said, bam. Here we go. So this is G right here. Alright, so we're gonna go get another color. Right. Yeah. Alright, cool. So we got y equals 1.8 x. So f is 1.8 x minus 2. Yep. And G is 4/5 x minus 2. Alright, cool. And so the tangent line, no. 2, 0. There we go. So yeah, this is 2. Good. Alright, so let's go back here. Alright. So, what we do, alright, cool. Alright. let's see what we're gonna do here. So let's add these in here. So we got f right here. So let's add f. F is 1.8 times x minus 2, and then g is 4/5 x minus 2, right? And as x approaches 2, such, and such. Okay? We're going to make this easy for us right here. We're just going to cancel these 2's out. It only makes sense, right? So it makes it easier for us. So the limit as x approaches 2 is 1.8 divided by 4/5, right? Alright, we don't have to include 2 anywhere, so we're just going to actually let loose that 2 and just focus on this math. You feel what I'm saying? So 1.8 divided by 4/5, right? Now we just got to use the reciprocal, right? Which is 5/4, right? So that cancels that down there. So now that's 1.8 times 5/4, right? Now 5 times 8 is 40. Carry the 1. 9.0 divided by 4, right? Or technically, we could have, hey, it's all good. It's all good. So 9.0 divided by 4, 9/4. Alright, so 9/4 is the answer to this. Alright, now how do we come to that conclusion? Right, we're doing limits, right? We're not focused on exact, you know what I mean? But we're just saying, we want to just get as close to the answer as possible. In life, you're just going to get as close as possible to an answer. You know, you may not be absolute at time, but you'll be damn close enough. You know, and that's all it takes to give you some confidence too, right? So, shoot, nonetheless, the limit of f of x divided by g of x as x approaches 2. When we look at the graph, we just take the f variable, right, the f function, we put it where f is supposed to be. We take the g function, put that where g is supposed to be, factor it, and see if there's any, common, factoring. And then if there is, we cancel those out, and then we go ahead and do the algebra. All right. So I hope that was clear for you guys. Let's go ahead and continue with this right here. Let's see, the graph, the graph, the graph of the function its All right, so the question is the graph of f, the graph of f, the graph of a function f and its tangent line at 0 are shown. What is the value of limit f of x divided by e to the power of x divided by minus 1 as x approaches 0? Alright, well, let's go ahead and figure this out. Alright, so let's go ahead and write this limit down here. So limit of f. Remember the tangent line, right? X is 0. So what we're going to have to do is still put 0 in for x, right? Still put 0 in for x. It only makes sense because guess what? X is approaching 0. X whatever x, that gotta go in here, and it gotta go in here. All right, and when it goes into here, right, it's 0. E to the 0 is 1. 1 minus 0, 1 is 0, right? E to the power of 0 is 1, and 1 minus 1 is 0, right? Which is a what? Indeterminate, right? And we can't have no indeterminates, so what do? We gotta take the derivative. You feel what I'm saying? You gotta take the derivative, alright? So, the derivative with respect to x, right? The derivative with respect to x, remember, so f of x is naturally, so this, before we add the 0 in, this is how it looks. This is how it looks. There's an x right here, x right there, right? Now we got to do the derivative of that. So the derivative of x is 1, right? The derivative of x is 1, right? So e to the 1 minus 1 What is e to the, oh, wait a minute, no. So the derivative of x is 1. The derivative of e to the power of x is e to the power of x. Alright? So we're still going to have that x approaches 0. Alright? So when we do the derivative of this, the derivative of x is 1, but the derivative of e to the power of x, right, is e to the power of x. Alright? Make sure we get that. So the limit of 0 goes into this function. So that's 1 over e to the power of 0 minus 1, which is e to the power of 0 I'm doing a class right now, y'all. You're gonna have to wait. You're gonna have to wait, Brody. And let me finish this. Alright? So e to the power of 1. Oh, guess what? When you do the derivative of these two, this is a constant, which means that this is going to be 0. Alright? So we got to also make sure that that's 0 in there. Alright? Now e to the power of 1 is 1. Alright? So 1 divided by 1 is 1. And so that's how you get that answer. Alright? And just reflect the graph of a function f and its tangent line. Alright? It's tangent line. Bam. Bam. Is at 0, which is right here. The line is at 0. Cool. And then we got this, so we already know that it's going to go like this, and it's like going to curve like that. But it's down actually at y equals -1. You know, the more you do this calculus, you start, you get a habit of actually knowing where things are. I'm telling you, like, I was like, what? I didn't even know that it could be right there. You know what I mean? But so that's what I'll show you. But yeah, as you can tell, based off of the information provided, we tried to include 0 for x, at the beginning, but we got an indeterminate because there's 0. You can divide 0 by 0 with the limit. So then we said, all right, well, cool. Let's just take the 0 out and go to the original function, which is x over e to the power of x minus 1. And we said, well, let's do the derivative of that. And so the derivative of x is 1, right? The derivative of x is 1, right? So that being said, there's an imaginary 1 right here. And we just eliminated that x and kept the 1. And we did the derivative of e of x, which is still e to the x, but we did the derivative of 1, which is 0. and that got us to this equation right here. So I hope you guys, got that. And I'm sure you did. I'm a good teacher. Nonetheless, keep it going. All right. Keep it going. Keep it flowing. So let's go ahead and do some more limits. All right. The limit as x approaches 4 is x squared 2x minus 8. Bam. Alright, cool. So what we're going to do is we're going to just include everything in there. You know what you're doing with these limits when you know you're the task is to throw it in, and if it don't work, if this don't work, then you take a derivative, use the L'Hopital's rule. All right, so we throw in there, so it's 4 squared minus 2 times 4 minus 8, and then it's 4 minus 4, right? And that is 16 minus 8 over 0. 16 minus 16 is 0, 0. You can't have that. So what we do, we take the derivative, all right? The limit of 2x minus 2, right? As x approaches 4, divided by 1, right? And that is, then you include the 4 in here, right? So 8 minus 2 divided by 1 equals 6, right? And that's the answer, is 6. All right. Let's do another one. I'm enjoying this. I'm at a, I was talking to a young breezy. You know what I mean? The first year in calculus. I was on. I'm seasoned in the game. You feel what I'm saying? So them, they gonna love. They gonna love some Dell. You feel what I'm saying? They gonna love some Dell. You ain't got no choice to love this. You feel what I'm saying? And so, I entered the study groups and woo woo woo. And then, they was approaching it and they saw me. It's like, oh, I like the way you talk about that AI, you know what I mean? And I was like, oh, for real? That's what's up. You're going to have to come up and get up some, you know what I mean? And then they came up and they, came and, see the business and see me prospering and doing my thizzle, you feel what I'm saying? And it's Moorish espionage, you feel what I'm saying? And they were just vibing with it, you know what I mean? International flavor. And so, it just correlates to something much more spectacular and inspirational. But I really enjoyed it about that. You see what I'm saying? And I definitely urge you, especially older men, or middle-aged men. How about that? Yeah, going back into college, getting that specific, specialty, working on your specialty. Because all I gotta have a specialty, man. You realize that more and more and more when you get up there, like, oh, now I need a specialty, man. And then you gotta be known for something. And then you become an assembly with the other brothers. You see what I'm saying? Especially us Moors, man. And then we, it's prosperous from there because you could work with one another and help and assist one another, and and we all have a skill which we can, help one another, especially the community. Once we're in this, our specialties within the STEM industry, we have something very, very, very valuable to the community. So, nonetheless, man, gotta have more men like that. The limit of x to the 7th power minus 1 divided by x to the cube minus 1 as x approaches 1. So we're going to just throw it in. Alright, we're going to throw in 1 to the x's. So 1 to the 7th power is still 1 minus 1. 1 thrown in here is 1 to the 3rd, which is 1 minus 1. And again, that's 0 over 0, which is indeterminate. You can't have that. So that means we take the derivative, right? Take the derivative, and then 3x squared. X approaches 1. Alright, so 7, we put in 1 to x right here, so 1 to the 6th power is 1 times 7 is 7, right? Let me make this, there you go. Cool. There you 1 in for x. 1 to the second power is 1 times 3 is 3. So 7/3 is the answer. Alright. We got it. I'm telling you, this is, at first it was like, but you know, you get it. It's alright. It's gonna work, man. It's just like programming. At first you didn't get it. It sucked. It's like, fuck. How do they understand this shit? You know what I mean? But then you just start getting it. You know? Shit. Especially when the universe brings you across other individuals who are pursuing the journey too, and y'all just form groups and y'all just have a greater good, right? You work on things that you enjoy doing, that help your community out, you know what I mean? Your state out, your nation, your tribe, your clique, you know, it makes your circle powerful. Those things, you see. And I didn't want to end this without going into you know, I fussed with the trigonometry, man. You know what I mean? I liked it in pre-calc, but once I got to cal, I said, fuck this trig. But it was no disrespect. It was just like, I didn't get the fullness. You see what I'm saying? So nonetheless, let's just go ahead and add some trigonometry in here, right? So the limit of sine of x minus cosine of x, right? As tan of x minus 1 as x approaches pi, as x approaches pi over 4. Alright, cool. We just throw it in there. Just throw it in there. Now we throw in pi over 4 to sine, right? Don't think too hard. Alright, sine starts at 1. At pi over 2, sine is at 0. Alright? Let's just go ahead and draw this right here. This makes it easier for a lot of people. So this is a unit circle, right? This is a unit circle. Alright? And then we got this line, and we got this line. Right here, this is pi. Right here, this is 2 pi. Alright? Now, what was this? Pi over 4. Alright, so pi over 4. So, alright, so this is pi over 4. Alright? That's 3 pi over 4. And this is 5 pi over 4. 7 pi over 4. Alright, cool. Bueno. Now, what is sine at pi over 4? 2 pi over 2. Right? So sine of x at pi over 4 is 2 pi. It's radical 2 over 2. Alright? Minus radical 2 over 2, because that's what sine and cosine is as well. Now, what is tan of x at pi over 4? Right? So tan of x is sine over cosine, which is radical 2 over 2 divided by radical 2 over 2. We got to do the reciprocal of that. Do the reciprocal of that, which is 1. It's 1. 1 minus 1. And that is 0 over 0. Alright, so since that's 0 over 0, what we have to do is take the derivative. Alright, we got to take the derivative. Alright, cool. Alright, so let's take the derivative. Alright, so what is the derivative of sine? Cosine. What's the derivative of cosine? Sine. Right? Well, it's negative sine. But like this. right? And then derivative of tan of x is secant x squared. Secant squared x. And derivative of 1 is 0, so we don't need that. So the limit as x approaches pi over 4 is cosine plus sine. So cosine of pi over 4 is what? It's the same thing. Let's see. So remember, cosine plus sine over secant x equals pi over 2 plus pi over 2 equals 2 pi over 2. Cancel that out. But that's divided by secant, even though we have secant x squared is the same as 1 plus tan squared x, which is 1. So 1 plus 1 equals 2. And so the answer would be radical 2 over 2. And that's how we do it. That's how we do it. Alright. Man, I like this. This is dope. This is good. Alright, this is very good. And if you guys have any more questions, man, we could do this all day. I'm telling you, this could go in all day. Alright. What time? Look at the time. Well, look at the time. 9. Alright, cool. Alright, let's just do a critical, let's do a critical point. Let's do this right here. Alright. 15, 13, 4.4. Yeah. Oh, there we go. Alright. It's trying to be like, what the hell? Yeah, boy. I want to make sure you guys got your money's worth with this, though. Your time worth, man. I'm serious. I'm gonna do another one. Alright, this is great, man. I want to be like, I'm telling you, like 80 years old, just doing my math. Enjoying my little tea or whatever, fresh air, right? Before the grandkids come over, right? I'm just, doing a little math, The grandkids, my son bring them over, my daughter-in-law, and they like, they don't know that granddad was just doing some discrete mathematics. You see what I'm saying? They don't know I was doing that, right? They think like grandpa was just chilling, in which I was chilling. I was meditating these numbers. You see what I'm saying? But it keeps me, efficient, right? So that I can give them the best of me, you know what I mean? And be, solid mentally. You see what I'm saying? So yeah, now we're still doing some trig, alright? So let's go ahead. So the limit of e to the 2 squared, e squared to the t minus 1 divided by sine of x as x approaches infinity, alright? So we're just going to throw it in there. Throw in the x. Just want clarity. That's all I want. Make sure it's clear. Alright. Throw in the 0 for x. We did that. E to the x is what? E to the 0. Because 0 times 2 is 0. E to the 0 is 1 minus 1. Sine of 0 is what? 0. So 0 divided by 0. Alright, so we can't do that. So we're like, alright, cool. So then we just bring the 2 down, right? E 2t 2x. And some people may be like, oh, but how did you no, dang, how do we know? We gotta do the derivative of this, all right? And it's the f and it's the g. So e to x, right? So e of f is what? No, f is e to the 2x, all right? Let's use g prime. F times g prime plus f prime times g. So e plus e times g prime. So g prime, this is the g right here, and then this is the f. That's the f. All right. So the f is e to x. The g is 2, because the 2x became 2. All right. Plus f prime, which is what? E to the 2x. Plus g. Still to the 2x. It's still to the same thing. So nonetheless, these two become 2e 2x. Alright? I just want to bring clarity to that, because someone could be like, but how'd you get 2x? Well, we did f and g, right? It is really the chain rule, to be honest with you. But hey, keep it going. Keep it pushing, keep it pushing. Alright. Yeah, exponential power, exponential function, the derivative of it is itself. So that's why it's that. It's this. Alright. Just keep it like it is. And you're going to put that derivative of sine, because the 1 is 0. When you do the derivative, that's just 0. So we're going to the derivative of first. I forgot the limit. As x approaches 0 is cosine of x. So let's go ahead and throw this in. 2e to 0, right? 1. 2 times e to the 2, 2, 0, divided by 1. 2 times 1 divided by 1 equals 2, right? Yeah. And that's that. Yeah. Pretty good, right? I hope it was clear for y'all. Yeah. If you have any questions, just let me know. But this is, you start enjoying. It's like, just do this. It's a good hour or two a day. And just head back to them. Man, I can't wait to go back to this. You know what I mean? Like some years later, and be like, damn, man, I was really getting them numbers. You know what I mean? Woo, 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 woo. Right? Years later, I'm looking back on this like, man, yeah. Hey, man, I was in that calculus class too. Check out my YouTube video. You know what I mean? Subscribe and like, man. I got some math problems on there, just to help you out, right? In that year, man, I'm telling you, I got some good stuff on there. You see what I'm saying? Yeah. So, okay, let's throw in this 1. So, sine, you throw in 1, that's 0. So, sine of 0 divided by 1 plus 1 minus 2 is 0 divided by 0. So let's take the derivative of this, which is cosine x minus 1 times 1. But we don't need that. And that's 3x squared plus 1. So 1 is 0, cosine of 1 is 1. 3 times 1 is 3 plus 1 equals 1/4. Alright? And that's the answer, 1/4. Alright? Let's do this right here. Yeah, it took me a minute to do this because this is honestly the chain rule. You see what I'm saying? Like, again, this is that times 1 because you got to do the derivative of this, which is cosine, but also you got to do the inside of it. So the derivative of the inside of this is 1, so that's 0, and you multiply, you take that out, right, and you make that a 1 right here, and you multiply that by the whole thing, which is still the whole thing. So as x approaches infinity, the radical x plus e to the x, right? And we know we just plug it in, right? 1 plus e to infinity is obviously, you know, without even doing any math, you know it's going to be infinity over infinity. You see what I'm saying? So now we just do the derivative of this, right? The derivative of this. Right? X 1/2, right? Divided by 1 plus e x equals the limit of 1/2 x negative 1/2, and that's e to the power of x as x approaches infinity, right? Equals negative 1/2. So the limit of x approaches infinity to 1 over 2 radical x divided by e to the power of x, right? And then you just do the reciprocal of that, right? And you times that by that reciprocal equals 1 over 2, what's that, e x radical x, right? And you put the infinity over there, which makes it 1 over infinity, which is 0. You see what I'm saying? Yeah, you include infinity right here to this exponential value, include infinity to this. So infinity times infinity is infinity times 2, which is infinity. And all that is under 1, which is 1 divided by infinity, is 0. Approaching 0. Alright. So, and I enjoy this with you guys. This is really good. Man, I've been wanting to get back to, oh man, this is good. And I'm like, I want to do one more, but catch you on the next one. Again, this was, we were doing the Indeterminates in L'Hopital's rule. Okay. We're going to work a little bit more on so many other ones too, no worries. We're definitely going to get through all these. Just want to give a break. Don't want you guys to do, you know. Some of you guys actually got this homework. So, you know what I mean? You're like, nah, P. Keep going. You know what I mean? I'm trying to get all the homework done and woo. You feel what I'm saying? Like, I'm telling you, man, if I would have somebody like me, you know what I mean? You know, going through, you know, the calculus years, but you know, I had, so it was already in me to be me, for me, you know what I mean? I had that in me to get through it so I could just be me, You know what I mean? Be that I, you know. Because we are just a part of this whole experience anyways. So let's just throw the 0 in for ln. Alright, and it's 0. So ln of 0 is infinity. Right? And infinity divided by infinity is negative infinity. Alright? Make sure you guys do that. This is another one. Do one more. So the limit of x approaching 3 as ln of x to the third divided by 3 minus x, right? Alright, let's throw the 3 in there. So ln of 1, right? Because 3 divided by 3 is 1. So ln of 1 divided by 0, right, is 0 divided by 0. Let's try that again by doing a derivative of this, right? Doing a derivative of this, you would have to use the quotient rule. Alright, so you take the denominator and multiply it by the numerator, well, the derivative of the numerator, so dx x minus derivative of x to 3 divided by 3 squared, right? And all that derivative of this is just negative 1. Yeah. What the? Yeah, let's see what that was right there. We're gonna figure it out. Alright, cool. So ln, let's just do the limit of ln. And 3 times 1 is 3. 3 minus x divided by 9. Okay. And you'll throw in the 3 right here. So the limit as x approaches 3. And x approaches 3 is ln of 0. Okay. Divided by 9. Right? I see what I did. I see what I did. Hold on 1 second. 1 second. So this 9 is still under the 0. And that's still over this right here. And that's still over this right here. Because you put the 3 in for the x. And that's indeterminate, so that's not the answer. It could be. Remember, this is a negative x, so it's a negative 3. So x divided by 3 divided by x. You do the reciprocal with this, which is 1. And then you do times the reciprocal of this. And you cancel that out. So that'd be 1 over 3 over negative 3. And there you go. Alright guys, I wish you guys a wonderful day. It was good doing some math with you. You know, I might be the only more that I'll be doing math with you, but I'm sure there'll be more after B2. So much up to us. I enjoyed this vibe, man. It was a good vibe, man. It was a good vibe. Fuck with y'all. Thanks for chilling with me. It's good to chill with my motherfucking family and do some math with my motherfucking family. You see what I'm saying? Because this is what we do. You see what I'm saying? We do these numbers. We high intellect. You feel what I'm saying? So it's such a pleasure to fuck with you. You see what I'm saying? And just do this thizzle. You know? So peace vibes. Shout out to the Moors. Rise up the Moors. Rise up. Get these studies. Get these. And you know. Get this material. You need it. You should do it. All right. Get high level mathematics so that society could be useful for you, and you can make our children happy, inspirational too. All right. So other than that, you know what I mean? I'm out. This is Delta P. Recognized game. Peace.